All right, welcome to section 2.7. Today we're going to be discussing parallel and perpendicular lines in the coordinate plane. Again, 2.7 is not required, it's extra credit, and the test questions will reflect extra credit as well. Let's go ahead and get started. So a horizontal line is considered a zero slope because it doesn't go up at all, it just keeps going sideways. A vertical line is considered undefined. It's not actually a function because it fails the vertical line test. A line with positive slope rises to the right, a negative slope rises to the left, or falls to the right, however you want to look at it. All right, parallel lines have the same slope, which means the same rise over the same run. So any two vertical lines are parallel, any two horizontal lines are parallel, as long as they're not coincident, which means they're on top of each other. Now, if we look here at perpendicular lines, they have a negative reciprocal slope. So right here, if I were to say that the slope of the first line is 3, let me get my pen out here, that it's 3, then the perpendicular slope would be negative 1 over 3. That's all we're talking about. We take it, I call it flipical reciprocal. I take it and I flip it upside down, and then I make it negative. So if I say the slope is 1/2, I take it and I flip it over and I say it's 2 over 1, and then I make it negative. So it's flipical reciprocal. 2 over 1. And since it's divided by 1, we can just get rid of it. But you'll need to know that one on the test if you want to get those extra credit points. Okay, so we talk about slopes of perpendicular lines. Their product is -1. Always. That's a hint. If you want to have perpendicular lines, their slopes have got to be multiplied together to equal -1. Now the slope of a line through two different points. This is where we get interested when we talk about rise over run. The rise is over here is the change in the y values. So y2 minus y1. The run is the change in the horizontal direction, which would be the difference of the x. So the slope literally is the change in the y's over the change in the x's. And you pick which ones you want to be x2, y2, which ones you want to be x1, y1. Regardless, that's how you find the slope. It's going to be on your cheat sheet right here under coordinate geometry. Notice we've got the slope of a line through 2 points right there. Also, we've got some slope-intercept equations that we're going to talk about. Some good stuff. So right here, slope of a line through 2 points. It's highlighted in yellow. You should know that. All right. Find the slope of the line through the given point. All right, now this one's told us that x1, y1, and x2, y2 are being chosen for us. But our first reason for this is because it's the equation formula, the slope formula. Now we substitute our points, we carry out the algebra, or simplify, and we get to reduce the fraction. Now, this is the slope given to us. Now we're looking for a slope parallel. That means it has the same slope. So we just literally say it's the same thing, 3/2. Talk about a perpendicular slope, we got to do opposite reciprocals, flipical reciprocal. So I flip it over 2/3 and I make it negative 2/3. Opposite reciprocals, negative reciprocals, flipical reciprocal, however you want to talk about it, helps you remember. Right here we talk about describe in words the slope formula. And you can come up with your own way of doing that. I'm going to keep moving. All right, we also now are going to talk about the slope-intercept form of an equation. This is review from algebra. Y equals mx plus b, slope-intercept. All right. Find the equation of the line passing through -6, 7 with the slope of -1/3. Well, our first reason is that's the form. That's the equation we need. Now I substitute in the slope of -1/3, and now I'm going to take my x and my y value. I'm going to plug those in. And now I'm going to do a little bit of multiplication. I subtract over and I find out that b equals 5. Now I can plug that in for b and I've got my final answer. We go on and we say let's find equation of a line passing through that point and parallel. So we need the same slope. So the coefficient of x is the slope. But right here there's no number here where my pen is. But we know there's a ninja 1 or an invisible 1 there. So we say the slope is 1. Here's the intercept form. We plug in the slope, we plug in our x and our y values, and we go ahead and solve, finding that b equals negative 11. I plug that back in, and I can either write it as y equals 1x plus negative 11, or I can do y equals x minus 11. Both will work. So, and the equation passes into the line negative 4, 1, and perpendicular to y equals negative 2/3 x minus 1. So it's got to go through a different point, and it has to have the perpendicular slope. So let's talk about the slope here. It's the coefficient of x. You find the slope of the line, negative 2/3. It's right in front of the x. Everything in front of the x right there. That's our slope. The slope of a line perpendicular has to have the negative reciprocal. So we flip it and make it negative. Gives us 3/2. So now we take our slope-intercept form and we plug in the slope. We plug in our x and y values. And then we do some algebra and we solve for b. We find b equals 7. Once I found that, I can plug them both in, and I've got my new equation. Notice how here it says negative 2/3. Well, here it says 3/2. That means they're perpendicular. And the plus 7 is the requirement to make it go through that specific point they gave us. All right, systems of equations are a set of two equations. When the graphs of these equations intersect, the ordered pair where they intersect is called the solution to the system. Okay, I'm okay with that. System of equations, they're pretty simple. We look here. Where do they cross? Blue and red lines look like they cross at 4, 5 or something like that. Regardless, the statement is true for both equations. At that point provides solutions to both the red and the blue line. So we call that the solution to the system of equations. All right, the graphing method is we just look for the intersection and we put an x and y and we're done. 4, 5. Here's some great examples. Where does this intersect? Somewhere down there, looks like it's going to be negative 3, negative 3. So there's my answer. I like the graphing method, but sometimes it's not quite so cute. It doesn't land exactly on an intersection point. This one's obviously 0, 0. And we look here, this is going to be negative 1, 4, it looks like. There you go. Tip, parallel lines will have no solution. They never intersect. So when you solve a system of equations, if they're parallel, guess what? They're never going to have a solution. All right, now the substitution method. This one's good if the graphing method doesn't yield a perfect intersection point. So, and also notice we only use the substitution method when we have the variables are equal to something else. So like y equals blank or x equals blank. That's when I think in my head, hey, I'm going to use the substitution method because I have a variable already isolated. So let's say I pick the second equation. And instead of writing x, I replace it with y plus 1 because they're the same thing. We call that substitution. Now here I distribute. I combine like terms. I subtract 2y over, or add 2y over. And then I divide by 3, and I find out that y equals 1. At this point, I substitute or replace y with 1 in the first equation, and I end up with x equals 2, and I write the answer as an ordered pair. There's my answer. That solution, 2, 1, will work for both equations. The elimination method is used primarily, you can pause and read that if you'd like. If you notice here we have equals 2 equals negative 5. This is when we use the elimination method because it's easier because all the variables are on one side and the numbers are on the other. That makes this elimination method work out really great. First step you need to worry about is getting one of your variable sets, either the x's or the y's, need to have the same coefficient of 2, see this? And one of them is positive and one of them is negative. I have to manipulate the equations to get to that point. So right here, this is where it talks about it. I manipulate the equations. I got to get them to be the opposite signs. The x-coordinate has the same coefficient but opposite signs, so we're good. We can start using the elimination method. And it says first step, make sure the coefficients of one of the variables are the same but opposite signs. I now add the entire equation together. I take 2x and negative 2x, I add them together to get 0. Negative 2y plus negative y gives me negative 3y. This gives me negative 3. So I do some algebra, I add the two equations together, divide by 3, and I'm good to go. Y equals 1. I plug that back into my original equation. And I say, simplification, I add 2 over, I divide by 2, and I get x equals 2. I write the answer as an ordered pair. 2, 1 works for this equation, always. And we use the elimination method. It won't always be that cute, though. See here? My equations don't automatically line up the way I want them to, so I have to manipulate them by multiplying the entire top equation or bottom equation by a certain number to make them work out. So right here, it looks like I've got, it'd be nice if I could get something really easy. I think that if I multiply the whole top equation by by positive 3, then I will end up with negative 3y on the bottom and 3y on the top, and that's what I want. So right here it says multiply the first equation by 3 to get to there. I use the distributive property to do that, and then right here I line them up. I've got this new equation, 3x plus 3y equals 18. It's the exact same thing as this because we used the distributive property, which maintains equality. So now I've got my equations. I add the two equations together. We end up with, see how the y's just kind of disappear? 3y minus 3y, gone. 5x equals 20. I divide by 5, and I get x equals 4. Now I plug that back into one of my equations, whichever one's easier. For me, it's the first equation. So I say, bada boom, 4 plus y equals 6, subtract 4 over, and y equals 2. I write my answers in ordered pair. The x equals 4, the y equals 2, and I'm done. So right here, how do you tell whether lines are parallel, perpendicular, coincident, or oblique? Remember, oblique is intersect but not perpendicular. And coincidence is parallel but on top of each other, so it doesn't count. So we talk here, are the slopes the same? No. If that's my answer, I've got a flow chart here. No, they are not the same. Okay, so are the slopes negative reciprocals? If it's no, then they're oblique. Now, if they are negative reciprocals, then they're perpendicular. Now on the right side, if I say, are the slopes the same? I say yes. Ooh, interesting. Now I ask myself, are the y-intercepts the same? If the y-intercepts are the same, then by golly, it's the same line. So if they're not, then they're parallel. If it is, then they're coincident. So right here, I ask myself, are the slopes the same? Yes. Okay. Are the y-intercepts the same? If they're not the same, then they're parallel. If they are the same, then it's on top of each other, and that makes them coincident. All right, next one. Here's a great equation. The slope of the line y equals negative 3x plus 5, that's negative 3. So there's my first slope. There's negative 3. So the second equation isn't given to me in y equals mx plus b format, so I have to manipulate it to get it that way. So I add x over. I'm going to solve for y. I add x over, I divide by 3, and I end up with y equals 1/3 x minus 2/3. I write it as in that format. So I notice now that my coefficient for the x is 1/3. Well, I ask myself, are the lines perpendicular? Are the slopes the same? Negative 3 and 1/3 are not the same, so I go no. Are the slopes negative reciprocals? Negative 3 and 1/3. Let's look at this a little bit. Are they the same? No. Little red tomato man. Are the slopes negative reciprocals? You can see that if I flip them and change the sign, then I can say, yes, they are opposite reciprocals. And I can say, yes, the lines are perpendicular. That's a great way to figure out if the lines are perpendicular. Slopes are negative reciprocals, therefore they are perpendicular. And right here, summarize what you learned in this section. We talked about parallel perpendicular lines, oblique coincident lines, talked about a lot of different things in this lesson, and remember, this is not required. This is extra credit for the test, and I hope this goes well.